In this lesson, we'll discuss another component in the Spring Framework, the component that supports aspect-oriented programming, or AOP. AOP people like to invent new terminology, so a large part of learning AOP is to learn the terminology, and here's the first one, concern. In software development, we can usually divide the functions of an application into groups, where the functions in each group are related to each other and serve a general purpose. For example, for an online retail application, we may divide the functions into user functions that deal with user accounts, like registering an account, editing account information, recovering password, and so on. And we can have product functions that deal with adding products, changing prices, searching based on product descriptions, and so on. And we can have other functions that deal with placing, fulfilling, and tracking orders. The general purpose of each function group is called a concern. For example, user management is a concern. Product and order management are also concerns. Most concerns can be implemented as modules of the application, and this modularization is quite important because it breaks down a large, complex application into smaller pieces that can be developed, tested, and changed relatively independently, and that makes building the application a lot easier. Unfortunately, some concerns cannot be easily put into their own modules, like logging, transaction management, and security. Virtually every method needs some logging. Almost every database access needs transaction management, and terrible things will happen if you forget security in some places. This type of concerns are called cross-cutting concerns, and they are needed everywhere, and there's no easy way to modularize them like other concerns. So what's so bad about cross-cutting concerns? Well, here's an example of transaction management. You probably didn't do this when you wrote JDBC code in your homework, but this is something you are actually supposed to do when you write commercial software. In particular, you should catch any SQL exception and perform a rollback of the transaction if an exception happens. However, rollback itself may raise an exception, so you'll need to catch that exception and do something with it too. Now imagine that you have to do this everywhere you access the database. That's lots of ugly boilerplate code scattered all over the application. It's tedious to write and difficult to maintain because if you want to make any changes, you have to change lots of different places and it's quite easy to miss something. So what is aspect-oriented programming? It's a way to separate out cross-cutting concern code into their own modules called aspects. Let's first see an example of aspect-oriented programming in action. Then we'll dig a little deeper and discuss the underlying mechanism. In this example, I have an interface called log task. This interface defines three methods, do something else, and hello. I have two implementations of log task. Log task 1 implement the three methods, do something else, and hello. And in log task 1, we hard code logging statements in the methods. For example, here I have a logging statement that says from log task 1 start doing something, and then another logging statement that says log task finished. Similarly, I have logging statements in do something else as well, and I have no logging statements in hello. So if we try this, I have some test code that we can use. Here in the main method, the test code will create a log test object, and this log test object has a has a field called log task, and we get the task field and we call do something else, and hello, and presumably we'll get output from those three methods. Here, notice that I did not initialize task field anywhere in this code. Instead, I have a getter and setter. If you remember the lesson on Spring Bean Container, you can kind of see that what we are going to do is we are going to create two beans. One bean is log test, the other bean is log task 1, and I'm going to inject log task 1 into this log test so that this task will be log task 1. And that is done in this bean configuration file. And I have log test, which is this one, and I have log task 1, which is a log task 1 bean, and I also inject log task 1 into log test here through the setter. So when I do test get task, I get log task 1 object and call do something else, and hello. So if we run this, this is the output. If we compare the code in log task 1, we can see that this is exactly the output we would expect. So do something outputs 2 log messages plus task 1 do something important done, which is this 2 log messages plus the output from the system.out print statements. And same thing for the do something else method. So this is the output of do something else method. Do something else, task 1 doing something done, and another log statement. And this is the output of the hello method, and there's no log statements in hello method, so no logging message for this method. So this is exactly what we expect, and there's nothing special about this. Okay, so then let's look at the second implementation of the log task interface, which is log task 2. If you compare this log task 1 and log task 2, you can see that log task 2 is very similar to task 1, except that there's no log messages in there, only the system.out print statements. So if we replace log task 1 with log task 2, and this is the output, and once again the output is exactly like what we would expect, just some printout from the methods in log task 2. No logging statements because we didn't put in any logging statements. Okay, now here's the thing. Logging, as we'll discuss in a different lesson later on, is quite important in application. So generally speaking, we would want to have those logging statements in our code. But if you compare log task 1 and log task 2, you can see that log task 2 looks a lot cleaner without those logging statements. But those logging statements are important, so we kind of have to choose between cleaner, more readable code or having important logging statements in there. Can we get the best of both worlds? Well, with AOP we actually can. So now let's change this once again. Instead of using log task 2, I'm going to use this bin called log task 2 with advice. Now I'm not going to show you what's in this bin yet. Let's run this code first. So if we run this code, we can see that now Although we didn't put any logging statements in log task 2, now log task 2 now gets all the logging output now. And it's actually even better than log task 1, because log task 1, there's no logging output for hello method. For log task 2, now even the hello method gets the logging statements before and after. Now if you say, okay, you must be trying to tricking me because you must be using a different class than log task 2. Well, I can prove to you that I'm not using a different class. This is indeed running log task 2. So we can change this one to, for example, task 2 method 2, and task 2 method 1, and task 2 method 3, and if we run this again, you can see that actually, let's add a new line to this so it's more readable. Yes, you can see that it's indeed running log task 2. It says method 1, method 2, method 3, and if you look at this code, it's just have those print line statements. There's no logging statement anywhere in this code, but somehow we get a bunch of logging output in our output. So where do this logging output come from? Well, again, I'm not going to show you the bin configuration yet, and let's see if I ask you to implement this, how do we do it? Now, here's a problem. Suppose I want you to implement something like this, and we'll define the problem here like this. So suppose we are given a class foo and a method bar, and whenever this method bar is called, we want to execute some code before the method call and execute some code after the method call. The restriction here is that we cannot change this class itself. Now, if you think about it, this is exactly what's happening here. We have this class. We didn't change the code in this class, but somehow when do something else and hello were called, and before each method call, we were able to run some code. After a method call, we were able to run some code, and so on, right? So this is essentially the problem we are trying to solve. Before and after method invocation, we want to run some additional code, and how do we do that? It turns out that we already learned not one, but actually two ways to do this from our lower division programming classes. The first way is to create a subclass of the original class foo. And in the subclass, we override the method bar. In the subclass method bar, we can add whatever additional code before the method invocation, and we can add whatever additional code after. And inside this method, we call the original superclass bar method to execute whatever logic in that method and get the return value, and then we return the return value at the end. This way, we added the additional code without changing the original method. And this is not even the only way to do that. The second way is to create a class that holds a reference to a foo object. And this class is usually called a wrapper class, as it's wrapped around the original class. Again, in this class, we implement a new bar method that calls the original bar method, but with additional code. So this is actually the underlying mechanism for abstract-oriented programming in Spring. It's essentially just creating a subclass or wrapper class and replace the original method with a method with the additional code. Once we understand this, it's easy to understand these AOP terms. So in AOP terminology, target refers to the original class, the full class. And proxy is a class with the additional code, for example, foo1 or foo2. Proxy interface is an interface that both the target class and the proxy class should implement. Having this class allows us to replace a target class object with a proxy class object. For example, in our application code, we will do something like foo interface foo, and then this reference can point to either a target class object or a proxy class object. And this is basically what we are doing here. When we declare a task, we declare it as a reference of the log task interface type. So later on, we can put either a target class object like a log task2 object in there, or we can put a proxy class object in there with the additional code that we can benefit from. And last but not least, advice is the additional code we want to execute. So in this case, the advice is this part of the code and this part of the code. So once the terminology is clear, it's now easy to understand what's going on with the bin definition. And now let's look at the bin definition and see what exactly is this log task2 with advice. And this is that bin. Let's look at it here. So first of all, notice that this bin is of type Proxy Factory bin, and this is a Spring Framework class. By looking at the name, Proxy Factory, you can kind of tell what it does, right? So what it does is essentially to automatically create a proxy class. So we already have the target class, which is log task2, and in fact, that is what this target property says. The target property says log task2. Now, whether we want to create a subclass or a wrapper class as a proxy, in any case, we probably don't want to manually do that, right? We don't want to create another class and manually type in another class extends log task2 or something like that, right? So what this proxy factory bin does is essentially it takes the original target class and it automatically creates a proxy class. Now whether that proxy class is a wrapper class or subclass, we don't really care. As long as it's automatically created by the proxy factory bin, that we don't have to manually do that, and that's all we care about. Now, in addition to specify the target class, we also need to tell the proxy factory bin a couple of other things. First is this interface, both the proxy class and the target class need to implement, and in this case is the log task interface. And also, we need to tell the proxy factory bin what is the additional code. And that additional code, remember, is called advice. and that's implemented in the login advice class. So this is the advice class. So in this advice class, there are a couple of methods, one called before and the one called after returning. By looking at the name, you can kind of tell that one method contains the code that's going to be executed before the method invocation, and the other one contains code that's going to be executed after the method invocation. Now, if you look at the code, it uses some method class, and it uses some class, and so on. And if you are not familiar with the API of those classes and methods, that's okay. That's not the important point here. The important thing to remember here is that before contains a code that's going to be executed before method invocation, and after returning contains a code that's going to be executed after the method invocation. And in fact, we can simplify this, and basically instead of doing all that and using methods or classes that we are not familiar with, let's just say we do a system.print, and we'll print out 1111 here, and we'll print out two here. And if we run the code again, we can see that now when a method is invoked, before that it prints out 1111, after that it prints out 2222, and so on. So going back to the bin configuration again, understand that this bin automatically creates a proxy class for the original log task 2, and the proxy class will have additional code in the advice, and both the proxy class and the target class implement the same interface, so they can be used in the same place. Okay, so moving on. Here's yet more AOP terminology. Join point is a point in the execution of the application where the advice can be plugged in. For example, before/after method invocation, before/after field access, and so on. Point card is a predicate that determines join points. For example, its method name begins with do something could be a point card to determine which methods should get the additional code. Introduction is to add new methods and/or fields to existing classes, and weaving refers to when introduction happens, which could be during compilation, or when the class is loaded, or during runtime. Here's some information about basic Spring AOP support. I say basic means that if you don't use additional tools like Aspect-J compiler, just regular Java compiler and Spring libraries. In Spring, advices are written in Java, of course, and the point cards are defined in XML or using annotations. Spring only supports method join points, which means that additional code can only be added when a method invocation happens. For example, you cannot add code before or after a field access. A field access would be something like a.b, and you cannot add code before a.b or after a.b. But if you say a.getB, then it becomes a method, and the Spring allows you to add code before this method is called and or after the method is called. And in Spring, aspects are woven in during runtime, And the good thing about that is you don't need any special compiler or special class loader. And Spring also has an additional term called advisor, which basically is a combination of advice plus point class, which we'll see an example in a moment. There are 4 advice types in Spring: around, before, after, and throws. As the name says, they allow us to execute additional code when certain events happen. For example, before a method invocation or after a method invocation, both before and after, or when a method throws an exception. In our example, login advice, you can see that login advice implements both method before advice, which is this one, and after returning advice, which is this one. And each of those 2 interfaces only has one method. So method before advice is an interface that has only one method before. After returning advice has only one method after returning. And by implementing both interfaces, we can add code both before and after. And as you can see, there's also a round advice, which presumably does both before and after, and we also have an example for that. This one, login interceptor, implements method interceptor, which is the so-called around advice. In around advice, you can implement this invoke method and add whatever additional code before, whatever additional after, and then you call invocation proceed to get the results, and then you return the results, which is pretty much we are doing here. And again, if all those classes like class, logger, invocation, and so on look kind of foreign or unfamiliar, that's okay. Let's add some simple additional code. So we'll say system.out.print. This time we'll do 4444, and then let's do system.out.print 5555. Okay. So this login interceptor class implements method interceptor, which is the interface for around advice. So how do we use this thing? Let's look at the bin configuration file, which is here. This is how we can use the login interceptor. And the bin configuration is slightly more complicated than this one. It's very similar, but has a little bit more that allows us finer control of what methods get the additional advice. So if you compare this one with this one, you can see that they are similar in the places where they both require a proxy interface, and it's the log task. They both require a target, and in this case it's log task 2. And here it simply says advice, and the advice is the advice here. But in the interceptor example, the advisor is not just the login interceptor, it's not just this one, which is the code here. It's actually something called an advisor. And what is an advisor? Well, remember we just said that in Spring, advisor is advice plus point cuts. So advice is here, and this is our around advice with code before and after. And what about the point cards part? Well, the point cards here says map the name do something star. Well, what does that mean? Let's run the code and see the results first. So this bean is called logged task 2 with advisor, and let's inject that one into log test, and we run it. Okay, so we get 44445555, and that's here and here. Well, let's add one more, just make sure that we are really getting that additional code. Right? So 5 4s and 5 5s. And log task 2 is here again, method 1, 2, 3, right? So notice that only method 1 and the method 2 get the additional code. Method 3 does not get the additional code. Why? Well, this is why. So remember, point cards is a predicate that determines join points. And what this means is that this point card determines which method would get the additional code. And as you can imagine, what this one says is that if a method's name starts with do something, then the method will get additional code. And it just so happens that we have two methods called do something and do something else. Hello, however, doesn't get the additional code. Now, if we want to do the other way around, well, all we need to do is say the method name should match hello. And in this case, the hello method will get the additional code, and the first two methods will not. And this is an example of the so-called point card. It's essentially a way to determine the methods or the places where the additional code needs to be inserted. And as you can imagine, this one is using simple name matching with a wildcard symbol star here, and in Spring you can also use regular expression to match method names. And just like dependency injection, you can also use annotations for aspect-oriented programming in Spring, but we won't get into that. If you are interested, please check out the Spring documentation. This lesson is a very brief introduction to AOP and AOP in Spring. Unlike inversion of control or dependency injection, we didn't get into too many details because it's actually rather rare for application developers to write AOP code directly. So for us, the more important thing is to understand the concepts of AOP, the terminology, the underlying mechanism of how it works. Once we understand the basics, it's much easier to understand and use Spring features like decorative transaction management and security. Both use AOP extensively, and both will be covered in later lessons. And before we wrap up, remember one more thing. AOP is very, very useful, but at the same time, it's a somewhat dangerous technique because advice code is separated from the main functions and it's introduced behind the scene. Debugging becomes a lot more difficult because human brains are just not very good at imagining code or analyzing logic that the eyes cannot see. So be very careful if you have to write AOP code yourself.